In this problem, you have a tall tower and the tower is of height h, which is what we need to find. A ball is dropped. It travels for about 5 seconds when it hits a electric wire and then loses a part of its velocity. So let us say that this velocity was v. It loses 1/5 of its velocity. So that means it becomes v minus v by 5 because it loses 1/5, but v minus v by 5 is 4v by 5. So that becomes its velocity, and then it continues to fall for 6 seconds. That means this time is 6 seconds till it hits the ground. Now the question that's asked is what is the total height of the tower, and the way we will find this is by just simply finding out what is the velocity v. So let us say that the starting velocity was 0 because it's anyway dropped. So initial velocity must be 0. And we are also told that the gravitational acceleration downwards is g equals 10 meters per second square. And we can take this direction to be positive. Now you know that initial velocity u plus at must be v, which means v must be equal to 0 plus 5 into 10, 50. Or it must be 50 meters per second, which means this velocity becomes 4 into 50 by 5, which is 40 meters per second. I can start by writing down that this displacement, okay, so let's call that S1, is ut 0 into 5 plus half a into t square. And S2, which is this displacement, okay, so if I take S2, then that is simple. That is 40 into t. T is 6 seconds now. Plus half a into t square. T square is 36. So now if I calculate this, this will cancel. This becomes 5. 5 into 25, 125 meters. And if I calculate this is 240 and this is 18. 240 plus 180. And that is going to give me 420 meters. This is 125 and this is 420. And so my total displacement or the total length travel, which is the height, is 420 plus 125, which is 545 meters. So this is my total height of the building. So this is one way of doing this. We'll also do this in a slightly different way. So instead of using all of these equations, so we proceed as we did earlier. We got velocity here is 50. And then the velocity becomes 40 and then it continues, right? Now I know my initial velocity is 0 and I know my final velocity here is 50, right? So that means for this period, my average velocity is 0 plus 50 by 2, okay? U plus v by 2 because it is moving with uniform acceleration. So my average velocity is 25 meters per second. So time into this velocity should give me this displacement, which is 25 into 5 or 125 meters. Well, that's what I got here. Now I know this is 40, which means this velocity should be easy to find, right? It is u plus a into t. A is 10. So a into t is 60, which means my velocity at the bottommost point is 100 meters per second, which means my average velocity for this period is 40 plus 100 by 2 or 140 by 2 or 70 meters per second. So I know the average velocity for this period and I know the time it takes. So average velocity into time must be this displacement. So this displacement must be 70 into 6, 420 meters. And therefore my total length travel is 125 plus 420 or 545 meters. This is another way of solving the same problem. And if I look at this, first we draw the diagram. That's the most important thing in any of these problems. So I have drawn these 4 different balls here. It's the same thing that is falling. This is one important time instant when it starts. There is some information given about it. And just before it hits the wire, that's an important time instant. Immediately after hitting the wire, is an important time instant because its velocity has changed. So there's a big change that happens between these two. And then finally when it hits the ground. So there are 4 key time instants, KTI. The 4 key time instants, so that you mark. Our entire problem solving was between this and this, and then between this and this. So the idea is that you split up the motion into the things that happen between these key time instants. So time instant 1, time instant 2, time instant 3, and time instant 4. The time between 2 and 3 is actually very small, but it's very important difference because at this point it was before it hit the wire, and at this point it was after it hit the wire. When you get a problem like this, you can actually list out the key time instance and then mark off the parameters, like for example, the velocity and things like that at those key time instance, and then you can solve.